Good evening, everyone, and welcome to the lecture of the topic inheritance for our subject object-oriented programming using C++. And I'm planning to take 3 to 4 lectures to cover up this topic. And we already know that inheritance is one of the essential feature, okay, of an object-oriented programming language. And in this session, we'll discuss how it is important and how we can implement inheritance using C++ programming language. Okay, so let us begin with the foundation that is required to understand inheritance concept in object-oriented programming. So let us first thing we must understand to understand the inheritance is that how it is related to the classification. What is the relationship between the classification and the inheritance? And let us first discuss this example before going to the generic relationship between the classification and inheritance. Let's take this example, what has been displayed here. So we have animal. So animal can be a mammal, a bird. So that means we are classifying. So animal is classified into, let's say, 2 categories here, mammal and bird. Again, the mammal is divided into or classified into 2. There are further categories. Let us say people, dog. There are other fish. It's many mammal category. Next is people. Okay, people we are classifying into two type, that is man and woman. Okay, and let's say a John is a man. Okay, and Mary is a woman. All right. So so this diagram shows how, okay, from the animal till man and woman, how the classification is done at various levels. So this is topmost level, animal is the topmost level, and man woman the bottom level. So this is the order, this is the how we progress. When you progress from animal and till the man and woman, this shows the order of classification. Okay, so when we go down from the top level, so we say it has been classified, it's a classification. Now inheritance is just the opposite. When we say that, let's say for example, we'll start from the bottom level. Okay, John is an instance of man. John is a man, or Mary is a woman. All right. So man and woman. So inheritance is that man and woman belongs to the category of people. Means a more generic class. So if we say man is a class, woman is a class, so we say that man, woman are of type people class. Okay, a man is a people, woman is a people. So the inheritance says that the man and woman are inherited from the class people. Similarly, people, dog are inherited from the more generic class, more generalized class, that is mammal. Similarly, mammal and bird are inherited from a more generic class, is animal. So what is my inheritance? Means they take some feature, they have some feature. So like definitely if you think that mammal and bird animal, so if you define some feature in animal, so mammal and bird will generally have those features. So people, whatever the common feature of a people will definitely be available as a feature of man and woman, that is inherit. So we say that man and woman inherit this feature from the people. People and dog inherit the feature from the mammal. So this is the relationship between classification and inheritance. So to come formally, we can say the classification arises from the universal need to describe the uniformity of collection of instances. Okay, so we to describe how a group of entities, a group of instances are related to each other. What is the uniformity among them? What is the common among them? That is been described by the classification. We say yes, men, we say classify men and women. Man has some uniformity, woman has some uniformity. Second, the classification is the basic idea for understanding the concept of inheritance. So this classification is done to show that yes, why the classification? Because when we say man the people are classified into men and women, so we said yes, there is this people, the men and women has been inherited from the more generic group, more generic collection of instance, that is people. That is the way to show classification, is to show that yes, this is the process of inheritance. And we can say the inheritance is the technique to realize the sharing of information without explicit redefinition. So when it comes to inheritance, what do we say when we say that men and women are inherited from the class people? That means it says that they share some information from the people class, some information which belongs to people class, or okay, are being shared by these two classes. Okay, inheritance means a new class can be derived from an existing class. That is the implementation related meaning of the inheritance. That is, given a class, suppose we have a class called people, so that means, and we have some again a group of class, okay, let's say men and women, so we can derive, instead of defining the main class independently, or redefining again, or women class again independently, we can inherit from this class. That will indirectly say that they share some information which is already been defined as a part of people class. Okay, instead of explicitly redefining this information in the class men and women. So the subclass, now term subclass indicate here, let's go back to the diagram to show that which is. So when we discuss about this a particular level, people, men, women, the men, women will be considered as subclass because they are at a lower level. There is a lower level, at a lower level, sorry, higher level, and people are at the lower. So people is a superclass, and men, women will be called subclasses. So the subclass inherit the attributes and the operations of superclass, that is called also called base class. Okay, so here the programming point of view, or we can say the object-oriented concept point of view, we can say that when we say a subclass, a class which inherits from another class, okay, then it inherit the attributes, okay, or we say the feature or the behavior, or the behavior and the action, okay, and the operations of the superclass. In addition, the subclass, which is also, we use the term derived, so this subclass, derived class, superclass, base class will be interchangeably be used in the presentation. Okay, so the subclass can define additional operation and attributes. So not necessarily that the subclass will be the same as the superclass. Okay, so subclass says that it derives, that means it has the feature of the base class, but in addition it will have some additional operation and attribute, it will have some additional feature. Okay, so coming back to the people, so people will have general feature. What the people will have? Okay, every people breathe, every people walk. Okay, so man and woman will be definitely having those information. Let's say man can walk, man can breathe, but man can do something additional thing compared to a people class. So some additional feature of men, okay, so will be defined here. Additional feature of woman will be defined here. So it is a specialization mechanism. That is, an instance of subclass we can say are the specialization of the instance of superclass. So people is a generic class, so man is a specialization, a special case, we say a special class. Alright, that's how we also say that this inheritance is a specialization mechanism. Also a generalization mechanism, that is inheritance of superclass, okay, instances of superclass generalize the instances of the subclass. So you take a John, Mary, okay, so they are the instances of the subclasses. So we can also say that when we say the men and women are inherited from the class people, so we can say that the John and Mary are generalized by the class people. Okay, so it is also a process of generalization, or is mechanism of generalization. So why to use inheritance? So First of all, to promote software reuse. So reuse don't mean copy and paste. Okay, reuse means already there, bring and copy paste. That is not. We'll see what is the demerit of copy and paste. So reuse mean by allowing the definition of hierarchy of classes, or defining the hierarchical classes with successive refinement of behavior. So whatever behavior is defined in a superclass, we can make some refinement on those behaviors. So we can refine or clarify. Maybe a generic behavior is there at the higher class. So we can refine. We can give more detailed behavior. We can add some behavior, additional behavior. We can put some restriction. So general class has some behavior which is not there in the subclass. So we can put a restriction on that. Then additional data member, additional attributes, features which is not present as a part of the superclass is defined in the subclass. So this is how we use the inherit. Secondly, it allow using the existing class libraries and tailoring them to the current. So the inheritance will help you to use the current class library and tailor them or customize them depending upon the requirement of the current situation. Okay, so how to use the inheritance? So it is been explained by an example. Let's say we have an imaginary goal that we have to design a class dog. Okay, let's say we have to define a class dog. What to do? Okay, so it says that the inheritance don't start from the scratch. Okay, if you have a very similar class like mammal already existing. Suppose you have a mammal. Okay, you don't start defining the dog from the scratch. You take the help of mammal. So inherit from the existing class instead. Okay, that is mammal. Okay, then that is dog inherit from mammal. Now mammal is a superclass and dog is a subclass. And you can add the additional attribute if at all required, which are only part of dog, not as a part of mammal, can be defined in the dog. As we discussed about what we can do, how we generally use the inheritance. These things can be done to a subclass. Okay, so this is how we use the inheritance instead of always starting from the scratch. Now, question is yes, why not copy paste? If we are discussing the concept of reuse, why not copy and paste? Now, what we can do is that copy the mammal class, paste it, change the name to dog. Yes, we can do that, and modify some existing, because there may not be exactly the same method used here. So let us modify some of the methods and add some new methods. Modify this. Okay, so done, fine. But the problem is that we had to get 2 copies of similar code and then change it. Like indirectly we can say you have to copy and paste, okay, and make some changes. Fine for small number of small classes, maybe will not face the problem, but it is danger for future debugging code. And the size is, and if you keep on copy and paste all the features which are there in the higher class, let's say class mammal, exactly copy in the dog. Okay, so you will keep on adding the codes in your line, and it's a problem in debugging. Also sometimes it may blow the size. Okay, so wherever the size is a restriction, copy paste is a dangerous thing. Okay, so that's why copy and paste is not the suitable way to reuse the things. Now let us come to the formal definition of inheritance that has been defined in various books. Okay, various cited books. So these are different. So inheritance is a mechanism of expressing similarity. The similarity is between two categories of objects. Two category of classes we can say. Second definition says that inheritance is the natural property of classification of hierarchy. Next, inheritance is the mechanism which allows one class to inherit the properties and behavior of another class, which this definition is more related to the implementation. We will see, or more related to the programming feature. Okay, that we can inherit the properties and behavior of one class to another class if there is a sharing. If there is a sharing between these two classes. Okay, so inheritance is the technique to define base class, derived class relationship. So if we able to find a relationship between two class, that one class is derived from, it can be derived from another class. So we can say that using the technique of inheritance, we can define this relationship between the base class and the derived class. Now let us see how, what is the relationship between the terms superclass and subclass. Now assume that here we have a class employee, a generic class, can be any type of employee, then, and we have a subclass manager. Okay, so we can say that manager is also an employee. So that means manager shares the information or features of employee. So whatever an employee has, definitely manager has. Yes. In addition, the manager can have some additional properties, or we can say attributes, or additional behavior. Okay, but whatever behavior the employee has, the manager will. So we can say manager can derive employee. So there is a superclass subclass relationship between employee and manager. So we say if a class A inherits a class A inherits from a class B, then B is called the superclass, or we can say base class of A. A is called the subclass or derived class of B. So superclass, subclass, or base class derived. This is how the terms are used. Superclass subclass combination or base class derived combination will be used in any book or any article related to inheritance. You will find this combination. So objects of a subclass can be used. So when we say we have already established this relationship, let's say employee and manager, then we can do this. That is, objects of a subclass can be used where the objects of corresponding superclass are expected, and it is valid. How? Because the objects of subclass share the same behavior as the object of superclass. That means if I say that a manager class is inherited from the employee, then I can say that wherever I need to use an object of employee, okay, I may use, or I can use the object of manager in that place without any error, without any conflict. Why? Because manager share all the information that an employee has. So there won't be any issue or any problem, okay, when I use a manager instead of employee. So that is how it shows the relationship between the employee and the manager. So let's see another example here. That's let's say a superclass person, a common class person. Okay, so this, what are the feature a person can have will be here. So an administrator can be a person, faculty can be a person, a student can be a person. All right, so we'll keep all. So person will have all the feature a common person will have. Okay, so like a person has a name, we can say, all right. Administrator will some additional feature. So administrator, faculty, student, all are subclasses of the person, and which is the superclass for all these subclasses. Now, when it comes to the C++, how we going to define this base class derived class relationship in C++? So that is been done through this syntax. That is, suppose we want a class X or a derived class to be derived from a base class. So this is the syntax. When we define a class, or when we provide the class definition, so class, the class name, let's say this is now when you define a class, derived class, so you write the class derived class name. Now since it's a derived class, it is inherited from a base class. That is provided by the syntax, the colon. Okay, the colon, then access specifier. Okay, here I use the term only access to indicate that what is the access specifier. Yeah, there has to be access specifier here. So, and then the base class name. Now make sure that when you define this derived class, the base class is already defined as a class. Maybe an empty class, but you have to define this base class definition must exist. Otherwise, we may get an error. Okay, then you proceed with the body of the class. That's all. Only one line: access specifier and the base class. Okay, so an inheritance access type. So here we can say access type or access specifier. So here the inheritance has some type in our C++. Okay, in C++, so we can inherit a base class, but inherit, there is a various type we can use. You can derive a class from a base class. So it is, so as the access specifier says that we can publicly inherit, we can use protected inheritance, or we can use private inheritance. Okay, when we do not mention this, when we do not mention the access specifier, then by default it is privately inherited. So if I say class X clone the class name, let's say Y, that means now inherit, this inheritance type will be by default private. So we have three types. Now let us we'll see in the subsequent slides how they are different. How, when we do private inheritance, what happens? When we do protected inheritance, what happens? What happens to the members? Okay, and when we do public, what happens? So we'll see how these different types are different from each other. First, public inheritance. Okay, so when you use public inheritance, when you use the term public in terms of access specifier, the private members, and we already know the private member, the meaning of private members of a class or a public member of the class. Okay, so private members, either it's a data member or a member functions of the base class, are not accessible to derived class. Okay, private members are never accessible to derived classes. However, okay, they are accessible through public member function of the base class. Okay, so private members are inherited but not accessible. Okay, public members of the base class are accessible to the derived class. So whatever the public members are present in the base class are all accessible to the derived class. That means they will be inherited. Okay, they are inherited to the derived class. Now come to the protected inheritance. Okay, so protected members of the base class can only be accessed by the member and the friend of the base class and any derived class. Now till now we have discussed public members, public data members or member function, or private data member or member function, but this term has not been discussed. So when we make a particular data member, okay, protected, okay, in the base class, then only the members of that class, that means base class, can access this members. Second, obviously friend as an exception, any friend to that base class can access those members, and plus any derived class. When you say protected inheritance, so protected members can be accessed in the derived class. Now protected data violate the data encapsulation, that's true. Okay, that is, changes to any base class of the protected members may require change to all the derived class, definitely, because we are accessing to the protected member. So this concept violate a little bit of the data encapsulation concept, but fine when it is required for our need, or whenever we need to use it, we have to use it. Okay, so here the case, what happens when we do protected inheritance. Okay, so let's say these are the public data of the base class, protected data, private class. Okay, so privates are not accessible, they are present, we can access through the member functions of the base class, but no, they are not directly accessible. Protected data accessible to derived, so these data only will be available in derived class, no other classes other than the friends. Okay, so that's the, and public always available, public, so public will be all become public, as we see in that, as in the case of public inheritance. So this is the summary of visibility of different type of class members, okay, on different type of inheritance. Okay, so here this side inheritance type, and on this side, okay, if what the based on the data type, okay, what is the base class member access specifier. Okay, so for a, when you are using the inheritance as a public, okay, that means the inheritance type is public, then all public data members are going to be public in the derived class. All protected members are going to be protected in the derived class, and all private members will be inherited but will be hidden. Okay, we'll show that how they are hidden, because we can verify the size. You can check this by the size of the object of the derived class, that the private data will be inherited but they are hidden, cannot be accessible. Next, when the inheritance type is protected, so all the public members of the base class will become protected. The class, the access specifier will now become protected in the derived class. And the protected access specifier data members will remain protected and private is hidden. Now, when we have the inheritance class type private, both the public data members, protected data members of base class will become private in the derived class, and the privates will remain hidden. So privates are never inherited but never accessible in the derived classes. Private are only accessible by the members of that class. So this is how the visibility is reflected when we use different type of inheritance, either public or protected or private. Okay. Now it will be, we understood the concept. Let us will see with an example. But before going that, so we must understand what is inherited from the base class. Okay. So in principle, a derived class inherits every member of a base class, every member. Okay, except its constructor and its destructor. Okay, its operator members. Okay, it cannot inherit the operator members. Whenever we define overloaded some operators in the base class, it cannot be overloaded. And friend, suppose some function is a friend of the base class, that doesn't indicate that is also friend of the derived class. So these are not inherited, except that every data member of the base class is inherited. May be accessible, may not be accessible, but definitely inherited in the derived class. Although the constructor and destructor of the base class are not inherited themselves, okay, it's by default constructor and destructor are always invoked automatically when a new object of derived class is created or destroyed. We'll see this. So it is not inherited, but we'll see that whenever an object of derived class is created, because it's a derived class of some base class, so before calling the constructor of the derived class, okay, it is going to call the base class constructor is going to be called. Okay, and we'll see with an example. Okay, so category of inheritance, we have seen the type of inheritance, and under that we have categories. So single inheritance, multiple inheritance. Okay, so a single indicate the simple, that means a class inherits from only one super. So here this is single inheritance indicate that one super derived class is inherited from only a single superclass. When the superclass is only one, it is called simple or single inheritance. And this can be of two types: single level inheritance, multi-level inheritance. Okay, so in the single level means there is one base class, and it is been derived by a one derived class, one base class derived class. Second step says that there can be multi-level, but there is one base class A, and it has been derived by another derived class B, and B becomes in a base class for some other derived class, let's say C. So that is multi-level. And multiple says that a class has more than one superclass. So this is how the category has been defined for the inheritance. So here is an example of single level inheritance. So employee, clearly says that employee is the base class or the superclass. So employee, here it's a diagram shows that this part is the data members. Employee has a name, employee has a number, and these are the member functions of the employee: get data, print data. Okay, and scientist, manager are a type of an employee, are okay, is an employee. So both derived from the class employee. That means they have the features of an employee. In addition, okay, a scientist, that means a scientist will have a name, will have a number. Definitely we can use the behavior like get data, print data to print this data. But in addition, it has an additional data member, that is publication. The scientist has publications, research publications, and we have defined two additional functions here. It get scientist data, print scientist data. Similarly, manager is derived from the employee, so manager has a name and a number. With in addition, the manager has a title. Okay, what kind of manager? So we define and club dues. As manager has some club dues. So these are the two additional attributes we have added to the manager in addition to the attributes or the features of employee. And get manager data and print manager data are the two member functions defined in the manager class. So all these things, that means the name, number, get data, print data, all are inherited in the manager as well as scientist. Now it depends upon what type of inheritance is used. Based on that, the visibility will be defined. The visibility of the name, number, get data, print data defined. So what is the type of this, what is the access specifier of these data members, as well as what is the type of inheritance used by scientist as well as manager. Let's see this example. So we have defined a class, that the class employee with a name, an array of character or a string with the name, and we have a number with integer, public. So the member functions are public, void get data. So name and number are taken as input and stored in the variable name and number, and just we print. So we take the input and print this. So simple classes, just for a beginning we are using simple examples. All right, next. So let us first discuss the derived class manager. So we define the derived class like this. So class similar to the class definition, only thing we'll see how it is derived. Okay, so here is the class manager, the colon, okay, public. So what is the inheritance type here? Public. Okay, we have already discussed what happens when publicly inherited, when the inherit type is public. Okay, so so what happens then? It publicly inherit the which class? Employee. So so that means the class definition of employee should present before the class definition of manager. All right, so manager have two additional, that means all the attributes of the employee are available here. Now we can access if they are public or protected, right? So we have additional attributes. We have character, title, double, dues or club dues. All right, and get manager data, we just print the manager data, title and dues. Input the manager data, title and dues, and we print using print manager data. Okay, simple remain as it is. But however, what happens in manager? We have the employee information. So, okay, since it is employed, so the character, name, int number, these are private, are available. They are not accessible directly. Okay, they can be accessed through this function, get data, print data, that means get employee data, print employee data. So this that means these two functions, the data, are available as a member of this class. Okay, only thing that the private members are not accessible. Similarly, class scientist, the inheritance type is public, employee, the base class. Okay, one additional data member, int public, int publication. Okay, now get scientist data, print scientist data. Okay, so three class definitions are over. Let's how to use them. Let's see that. Okay, this is our main function. Employee E1 creates an object of class employee. Manager M1, okay, creates an object of class manager, and scientist creates an object of the class scientist. E1 get data, E1 print data. Okay, so we'll take the input for the employee. Okay, that means a name and a number for the employee, and we print it. Now M1 get data. Get data defined inside the class manager? No. However, get data is a member function of the class employee. But since manager, okay, has inherited from the class employee, so this member function is, and again it's a public, so this member function is publicly available. So we can access this member function directly. So M1.getData will successfully call the getData function for the object M1. Okay, so what is going to do? GetData is going to take the input, two input, that is the employee number and employee name. Okay, because since manager is also an employee, it will have a data, it will have the data member, E number, employee number, and the employee number and the name. So these two data member also available as a manager. So a manager will have an employee number and a name. So those data input is taken via using the get data, and it is printed using the print data. So this will print the base class attributes, base class information of the manager. Now to print the manager data, input the manager and print data, we will use the manager function, which is defined inside the manager. Oh, there is a mistake here. This should be small m. Okay, this should be small m. All right. So m1 get manager data, it is going to take the input, the data which has been defined inside the manager class. Okay, and so this is common. These are common. Only thing is that we can see that the publicly inherited data members from the base class employee to the derived class manager are accessible through with reference to the object of manager class. Okay, object of manager class. Similarly, S1 get data, S1 print data indicate that the get data, print data functions are available in the derived class scientist, so that S1 we can call these data members through S1, okay, to take the data, take the information, to the data member information for the scientist object. Okay, and print it. Let us execute this and see how it works. So this is I think this is the class which we have discussed right now, and let us see how it works. Let us execute it and see how it works. Okay, so I run it. So first the employee, right? Sorry, I think I have done some modification to this, so we are getting this information. I think I added some all right, so I'm printing the values of the employee. So here I'm adding one thing: size of the employee object, size of the science object, to indicate that how the data are how the data members are inherited. All right. So employee, what is the size of an object of an employee? The character name 20 bytes, integer 4 bytes, so 24. All right. And scientist, one integer extra, so plus 4. Okay, should be plus 4. So that is indicated here. Okay, size of the employee object is 24, and size of scientist is whatever it. So include, you see that 24 plus 4, that indicate that even the private members are inherited. Okay, so the employee number and name both are private members, both are inherited. Only thing is that depend upon the access specifier. Okay, the private members are not accessible. Okay, are only accessible through the base class member functions. Okay, so it is waiting for the input for the employee data. So I think first one is the name, then the number. Okay, so name of the employee, let's say AKM, and let's say number we give, let's say 100. Okay, so it is printing the name and the employee. So I am not use any formatting here, just to indicate that how they works. Now for okay, now it takes the manager data. Okay, for the manager data we call this. All right, then it calls this it is the get data function, and print data is called for the manager data. Now let's say manager, let's say MMS. Okay, and its employee ID is, let's say 200. Okay, so it's printing the information about the, and so print data, print manager data, print data for the manager. Okay, the employee data for the manager. All right, so next is manager data. It is waiting for the get manager data and print. So the get data, print data has been called for taking input for the employee information of the manager and print the employee information of the manager. Now we're going to take the manager data. What is the manager data? First is, if you remember, the title and the dues. Okay, so title is, let's say, assistant manager, and due is, let's say, 20,000, for example. Okay, all right. So by calling the feature, the function print manager data, we are printing the attributes or the data members that belongs to only the manager class, that we have already seen that here. So we print the title and the due here. All right. Now let's come to the scientist. Now scientist. So scientist employee information. First, the employee name, let's say KKS. Okay, and let's say number is 300. So the employee ID of the scientist is employee name of the scientist is KKS and his employee ID 300. Now number of publication, let's say 24. All right. So this is how, okay, we can use the functions. We can, here is an example, shows that how we can use the base class functions derived in the, or which are derived inside the derived class using the object of the derived class. So we have not defined. You can very well see that, have we defined the class get data function, print data function inside the derived classes? No, we have only manager data, get manager data and print manager data, but those functions are also available. That's why we're using an object of manager, we can call those two functions. Similarly, using the object of scientist, we can call those two functions. Okay, so let's do go an extension to the current example. Okay, let us see how we can do that. Okay, so we have class employed protected. Okay, now access specifier number private, they are protected now. Okay, just want to show that how it is done. Then so all the things remain the same. Only thing is that the data members of the base class are now no more private, they are protected. Public, get, now we have modified the name of the function. Get function, get the input, and print function, print the data members. Okay, class manager, public employee, title, double dues, public, get data, print data. Now we have get and print. Now we modified name to the get print data. Similarly, scientist, publicly inherit the employee, then publication, get data, print data. So what happens here? What the difference we found from the previous example? Now since the inheritance type is public, but the data members are protected, these data members are protected, are of visibility type protected here, so we can access these data members directly in the derived class. So we can see that in get data, we can take the input for the employee name and employee number directly without help of the get function or the print function of the derived class, because they are protected, they are no more private, they are protected, so they can be accessed directly in the derived class. Okay, as we follow this rule, right? If you remember, yeah, this way. So the data members were protected. Okay, and when we use public, okay, protected remain protected. Okay, when we use public inheritance and data are protected, they will remain protected. So the employee number and the name both remain protected in the class manager as scientist. That's why we are able to access them directly. Name, number, publication. So you see that the name and number are not defined here. These are not the data member of this class, they are the data member of employee class, but because inherited publicly, these are available as a protected member of these two classes. Okay, when we can print these informations here. Okay, so what do we do here? We create an employee E1, manager M1, scientist S1. No more has to invoke the get print function for the employee, because these data are protected, so we can print. So for employee only we use E1.get, E1.print to print only employee class data, but for M1 we can get all the data members including the data member of the employee using this function. Also we can print them. Similarly for scientist, you can take all the data members, okay, the base class data member as well as derived class member using get data and print data. Let us see this example. Okay, here is that example. for the timing, uh, we're going to not discuss about the constructors, so I'll put them in the comment. We'll come to the discussion of how the constructor is used later on. So just for the timing, I'm keeping a restriction on putting comment on this, so that we'll discuss this later. First, let us discuss how the protected data members are publicly inherited in the derived classes. Let us see this one first. Okay, so we'll discuss about the classes later. We'll see how the constructor are being used. All right. Okay, so let us run this first for the employee. Just a minute. I think I have to call the functions. Oh, I have to call all these things. This is a comment here. Okay. All right. So first, it is waiting for the employee data, employee class data. First, the employee name and the number. Name is, let's say, AKM 100. Print the base class data members, AKM and the 100. Okay, now waiting for the base class data for the object M1. So M1 get data. M1 get data. You can see here what is the M1 get data. So in M1 get data, we first take the manager name, manager number, which are the data members of the base class, then the title, then the dues. Okay, so name is let's say MKS, employee ID 200, its designation is, let's say, assistant manager. Okay, and dues is, let's say, 30,000. Okay, so first line prints the information about the derived information. The name of the employee is MKS, then the 200 say the employee number. He is an assistant, designation is assistant manager, and his club dues are 30,000. Okay, now for scientist, same scientist name is, let's say, TTK, and its employee ID is, let's say, 400, and the number of publication is, let's say, 50. Okay, so it indicates that, oh sorry for the formatting, because I'm not used the any formatting for this. We can do that by using endl. Okay, so name of the scientist is TTK, its employee is 40, and 50 is the number of publications. So yeah, please pardon for that, because I'm not used the formatting for this. You can do it better. Okay, please modify this one. So yes, this formatting should be done. All right, so we can see that here how when the data which are protected are inherited and also can be accessed directly by the member functions of the derived class. That is the thing we are going to discuss here. All right, next, the concept which we'll see now, because we can derive the data members, okay, using public inheritance or protected inheritance. There is a concept comes overriding. Now this is a scenario. Overriding is a scenario that may happen during the inheritance. Okay, so what is it? If attributes or methods defined in a subclass have the same name as the attribute or method defined in the superclass, then a technique called overriding is used to solve the conflict. This technique cannot be applied by the user explicitly. It is done implicitly. Now let us see the scenario here. What I've done, we have given the employee character name, number. Now let us assume that in the derived class manager there is also a data member called name and number, the same identifier. Okay, it means the same identifier. This is the scenario. So there is a confusion because these are protected, these are data members are inherited. At the same time, there is also defined new data members are defined in the manager with the same name. Which one to choose? So it's a conflict. Okay, employee has the same data member, name and number. Manager also has the data member with the same name. Okay, okay, employee number and the name. So how to resolve it? So this conflict is resolved by using the concept technique that is called overriding. Now what is overriding? That means the function in the derived class with the same name, because we are saying about the name of the function, because all right, so mostly we discuss about the function, we can define the function. So the function in the derived class with the same name, okay, okay, same name, that is for same function name or the same variable name, will override the functions or variable defined in the base class. So this is the solution. This second point gives the solution when this kind of condition conflicts occurs. Okay, that means whatever variables or the function name which is same as the base class is defined in the derived class, they will override, take over. Okay, that means the base class data members are suppressed. Okay, base class data members are, when we say with the, let's say we have name employee, name we have employee in employee uh, uh, name or number. So inside the manager we are using the manager member function or any main object. When we refer the employee name or the number inside manager, that refer to the name and the number defined inside the manager, not to the name and the number of employee class. Okay, so that is overriding. So the name and the number defined, okay, the data member defined in the manager class override the name and the number defined in the employee class. That is called overriding. Okay, we'll see an example. So but yes, but what happens now? Now it is suppressed. So that means the name and the number of the base class is not, okay, it cannot be accessed directly, it can be referred directly inside the derived class. But how can I access? Yes, we can still access, because I have to access. There I inherited. Okay, there is a, like now here we have the same name variable of the base class, name variable for the derived class. We have this kind. Now how to refer it? By default when I say name, it is of derived class. So then how can I access? Yes, still can be accessed. So we can still invoke or get the override function, okay, with the scope resolution operator. We, to access the variable of the base class, we can use the scope resolution operator. We'll see this example. Okay, we can still access. So when a base class member function is overridden in a derived class, it is common to invoke the base class version and some extra. So whenever we generally have a base class, when we have a base class member function overridden in the derived class, that means we have a function in the base class with the name f or with the f, and also have the same function in the derived class. It is commonly expected that we define this class, okay, invoke, like we have the base class version, we invoke the base class version of the f with, we do some additional work inside the derived class. That means what is the meaning of, what is the literally meaning of defining the a function having the same name as the base class? That means it is, we can say, a higher version or a upgraded version of the base class member function. That means that's why it is commonly found that it is it will invoke the base class member and it will do some additional class. Okay, so a derived class can override a base class member function by supplying a new version or with that, with, okay, function with the same arguments. Okay, so a new version, whenever we need to define a new version of a function in the derived class, we do in this way, or we take the help of overriding. Not using the scope resolution operator to the reference and the overridden base class member function will cause infinite recursion. When we don't use the scope resolution operator to refer the overridden base class members, then it will lead to recursion. So when we use base class member function, you must use the scope resolution operator with the base class name, otherwise it will lead to the recursion, infinite recursion call to the derived, to the overridden member function. Okay, so we'll see the example. Let us see an example here of the overriding. So the class employee, and we have a we can see a parameterized constructor with text two parameters. All right, that is we have already defined the private member, that is as a first name and the last name. We print the data and we have a destructor. Okay, now we have here, so employee, okay, the parameter constructor, it allocate the memory for the first name and copy the name that is provided in the first parameter fst to the fst name. Similarly, allocate the memory for the lst name and copy the data which is provided in the lst to the lst name. Okay, and print the first name and last name here separated by the space. Destructor, delete the data. Okay, this is the base class. Now derived class. Hourly worker. Hourly worker publicly inherit the class employee. Okay, so private members are inherited, but only can be accessed through the member function of the base class only. Okay, not accessible directly. Now public. So publicly we so private we have the additional data members along wage and hours along with the first name and last name. Okay, and hourly worker, the parameter constructor, it takes two parameters. Okay, that is first, that is character that indicate the first name and last name of the hourly worker, which are the data members of the employee class. Additionally, it will take the wage and number of hours. Okay, and let us see how this parameter constructor is defined here. Here it is, hourly worker, scope resolution operator, okay, the parameter constructor, first the first name, last name, double hour, then double wage, colon. First thing is calling the parameters constructor of the base class. Here explicitly first we are calling the parameters constructor of the base class. Okay, so it calls the employee, the parameter constructor explicitly, and pass these two to update the employee, the data member of the employee class, that is first name, last name. So first name, last name of the hourly worker is updated here. Don't think that it is going to create an object of that. So here it is calling the derived the parameter constructor of the base class for the hourly worker. Okay, so then it updates hours and wage. Okay, so you see that this step update the base class information, okay, through base class constructor, base class parameters constructor, and then update the data members of the derived class. Okay, we print it. Now since we know that we cannot access the first name, last name of the employee directly, so what do we take? We take the help of the base class function. Now we see that we have defined the print function here, and the name of the print is same as the print function of the base class. That means what happens here in hourly worker, the void print, this print function override the print function which print the first name and last name, okay, in the employee class. Okay, and whenever we refer print here, that means it will call this print. When we will, for an hourly worker object, when you call print function, it is going to call the print function, derived class print function. That means even if the print function of the hourly the employee is available here, we cannot, whenever we refer only print, it refers to the overridden print function. So this print override the print of the employee. But how to use it? Yes, we can call through the scope resolution operator. So what I will do here, see that within the print, why are we doing that? Because it's a next version. Okay, so to call the base class version, we just don't write print, as you told. If you write print, it will recursively call this function and fall in a infinite recursion loop. Okay, so employee scope resolution operator print indicate that, okay, we are calling the base class version of the print. Okay, so now this print is not the call to the overridden function print. It indicates clearly that this print refers to the print of the base class of the employee. So it is going to call this function. So it is going to print the first name and last name. Okay, after that we call get pay. Okay, so get pay is going to return, okay, calculate the wage multiplied by hours to get the total payment for the hourly worker. Okay, so here it shows an example of how print is overridden here, and still we can call the base class version of that print function. Okay, so here is the example. So main, let's say we've created a hourly worker object h with passing all the parameters. So first, Bob and Smith indicate the first name, last name. This is passed to the explicitly called parameterized constructor of the base class to update the first name, last name, and 40 is the hours and 10 is the wage. Okay, and when we call h dot print, it is going to invoke this function, but first it is going to call the base class version of the print, which is going to print the name of the employee, first name and the last name. Then it is going to call the get pay, already the form, which is already another member function of this class. So get pay is invoked to calculate the wage and hours for the object h, and it is going to print the pay of the object h, okay, for the hourly worker h. Okay, and let us see how this is executed. And this is the class. Yes, this is the class we were discussing about it, and let us see how it works. So okay, the copying of a string to this is giving a warning, and for the timing I will ignore it. Let us see how it works. Okay, so you can see that it is printing the first name, last name. So it is, I have only called is to the call to the overridden print. Okay, so this print is going to first print the name, that is Bob Smith, and is calculate the pay, that is wage multiplied by number of hours. Okay, the wage is 10 with the 40, so the total pay is 400. Okay, so this is an example of overriding a function, okay, a member function in the derived class, okay, which is the same name as the base class. Okay, so for this session we'll stop here, and we'll continue our discussion in the next class.